Today we're in section 7.5% of change. Okay, good news is if you took 7th grade math here last year, you already learned this. Okay, so it should be somewhat of a refresher. If you didn't, then, just pay attention. We're learning one formula, and that's pretty much the basis of the entire lesson. All right, so percent of change. It gives us a scenario here in the top section, which we'll read in a second. But I want to focus on this bottom paragraph down here. It indicates how much a quantity increases or decreases with respect to the original amount. So basically, it's always going to be a comparison with the original amount. If the new amount is greater than the original, it's an increase. If it's less than the original, it's a decrease. So we're always comparing it to the original amount. All right, so we have to have that order in mind. We need to know the formula. And the formula for percent of change is the amount of change, which we call the AOC, divided by the original amount, which we call the ORG. So what you see in parentheses is what I expect you to write at the beginning of every homework problem tonight. The AOC over ORG. Okay? Then we'll make our substitutions and convert that to a percentage. Okay, so let's read this scenario, this top scenario now, and use our formula to figure out what the percent of change is. So, and if you picture this, I think it would be kind of cool. It actually probably is a picture in your textbook. All right, so let's read the example. It says the International Balloon Fiesta takes place every year in Albuquerque, New Mexico. So in 1999, 903 balloons participated. Can you imagine 903 hot air balloons? No, I'm talking the huge hot air balloons that you can ride in. Isn't that kind of crazy? So in 2000, 1,019 balloons participated. By about what percent did the number of balloons increase from 1999 to 2000? So we go with our formula. Amount of change over the original. Remember, it's all compared to the original amount. So it doesn't matter which one's bigger than the other one. I'm just subtracting the two from each other. So 1,019 minus 903. Before you go straight to your calculators, let's talk for a minute about a way that we could actually subtract these using mental math. All right? So what we can do is we can round these to the nearest value that would be easy to subtract. So 1,019 is pretty close to what? 1,000. And 903 is pretty close to 900. What is 1,000 minus 900? 100. Now, let's go with our leftovers, the 19 and the 3. What's 19 minus 3? 16. So 116. See how we did that? Okay. Now, calculators will be allowed on the next quiz, so you don't have to worry too much about it, but the more we strengthen our mental math skills, the better off we're going to be. So we're going to really be working more on that in this class in the coming weeks. All right, and then the original amount is where we started. That's 903. So now I have my fraction, and I need to convert this fraction to a percentage. Well, the easiest way to do that is to change it to a decimal first. So we go 116 divided by 903. And what do you get? It's a really big repeating number. So whenever it's a really long repeating number, how many decimal places do we go out? 3. So it doesn't matter what the fourth number is. We're just going to go out 0.128. But now that we have rounded our answer, meaning that it was a repeating decimal, but we've now shortened it, it's going to be approximately 12.8%. We need to make sure we approximate our answer.
So would it be okay if we did approximately 13%?
I would be okay with that, but because we went out 3 decimal places and it's not the same number repeating, 12.8% would probably be the more accurate answer. Okay, but because we rounded, if you ended up rounding to the nearest percentage, that would be okay also. All right, so this whole idea of the amount of change divided by the original is really what we're going to spend the majority of our class hour today talking about. All right, so in the checkpoint, it gives you a format that is more, basically it mirrors more of what you would see on homework, quiz, or test. Just a point blank, this is my original amount, this is my new amount, find the percent of change. Okay, so we always start with our formula, AOC over the original. What does AOC mean again? The amount of change divided by the original amount. So between the original amount and the new amount, how much did the values change? 5. So 5 goes in for my AOC. And then my original amount is 20, and there's my fraction. Now in my calculator, I go 5 divided by 20. I get what as a decimal? 0.25, which is 25%. All right, go ahead and do the next two. Okay, so when we subtract on the second one, did you get 39 over 150? All right, and then did you get 26%?
Yes.
Okay, good. On the third one, when you subtracted, did you get 88 over 55? Okay, now what do you think this tells us about our percentage?
It's going to be okay.
That the amount, anytime we see that the amount of change is actually more than the original, that tells me that my percentage is more than 100%. Okay, does that make sense? So if I had a value of 50 and I said, what's 100% of 50? You would say 50, right? So if you have a value of, say, 88 out of 55, you know it's going to be more than 100%, and it is. It's 160%. Now, one other thing we need to talk about. So this answer, the first answer, is going to be 2 points on your homework. The second answer, this INC, that's indicating that this is a percent of increase, okay? Now, in this example, it told us that it was a percent of increase. On your homework, it's not going to tell you. You have to decide, is it an increase or a decrease? And the way you do that is by looking at the original setup. From the original amount to the new amount, if the value goes up, it's an increase. If the value goes down, it's a decrease. So on all three of these, because it was percent of increase example, they're all an increase. Does that make sense? Okay. So if the original amount is 40 and the new amount is 30, is that an increase or a decrease? That's a decrease, okay? So it's going to be 1 point on your homework to indicate if it's an increase or a decrease. Okay? All right, that's it for example 1. Example 2 looks at it on the flip side, and it's just percent of decrease. Percent of decrease. All right, so again, we're still using our formula, AOC over ORG, the amount of change divided by the original amount. And in this format, when it says from a number to a number, from whatever that number is, that's my original. That's my starting point. And then I'm going to some other value, okay? So 512 is my original, and I'm going to 320. How do I find my AOC? What do I subtract?
512, 320.
Okay, I just need to know the difference between those two values. It's going to be 192. Now, what would I divide it by?
Original?
The original amount, which is what? 512. Okay, go ahead and change that one over to your percentage and then do the other two. Alrighty, y'all done? All right, so what I did was I went ahead and set up my original fractions on all three of them, okay? So how did I get 577? Where did that number come from? I subtracted the new amount and the original amount from each other. And same thing with 394, right? I subtracted these two values to give me my amount of change. And then remember, my denominator is always my original amount. It's always my starting point. So that's how I came up with my fractions. And now I'm going to go back, change them to decimals, And when needed, I'll round out to 3 decimal places and then convert to my percentage. Now, is this going to be an increase or a decrease?
Decrease.
It's a decrease. Actually, they're all decreases. So we just make sure we write DEC. All right, for the second one, this was a repeating decimal. So what do you notice that's different, guys? What do you notice that's different that I put in there? The approximation sign. Make sure you remember to do that. All right, same thing with the third one. It's another rounding one. That's no big deal, okay? So going back to Avery's question, if you were to round to the nearest percentage, I'm not going to count off for that, but I do prefer to see to the nearest 1/10 of a percent. All right, okay, Janie?
The second one, like approximately,
Yeah, that's what I just said. It's fine to round to the nearest percent. That's fine. All right, so now in example 3 and 4, we're going to switch gears just a little bit and approach this from a different angle. We're now going to find the new amount. Okay, so now it says there were about 198,000 spectators at an action sports event in 1995. You know that's a ton of people, right? Like, that really can't even fit in a stadium. Hardly. I mean, at a football game, you'd have an average of 50 to 75,000 spectators. That's more than double. So I don't know how accurate it is. Maybe it's in like this just crazy arena, like huge arena. But we'll go with it, okay? 198,000 spectators at a sports event. The number of spectators actually even still increased by about 12%. From 1995 to 2002. So how many spectators were there in 2002? There are 2 ways to find the new amount. One way is a 2-step process that first involves finding how many people does 12% represent. How many people is that? Well, how do I find the percent of a number? What do I do? Change it to a decimal and I multiply it. Whether it's an increase or a decrease does not matter at this point. I just need to figure out how many people is 12% of 198,000. What is it? 23,760. But that's not my answer. Now I take that value and would I add it or subtract it from the original amount? Why would I add it?
Because it wants to be added.
Because it is an increase. So if it was a decrease, what would I be doing in step 2? I'd be subtracting it. So add them together and I get my new total. And make sure you label anytime it's a word problem. The only difference with step 2, if it's a decrease, is you subtract. All right, so finding the new amount. My feeling is that most of you are probably going to prefer this method over example 4. But there is some value in at least still exploring the option of example 4. I don't care, and your homework instructions are not going to say what method to use. It's just going to say find the new amount. That's it, okay? So you can use whichever method you want. In example 4, instead of, I want to look at one slide before I got to get there. Okay. In example 4, instead of changing the percent to a decimal to start with and multiplying, what they do is they use the baseline of 100% and they add or subtract whatever that percentage is. So in example 3, do y'all remember it was 12%? Y'all remember it was 12%, the one we just did? Well, instead of changing that to a decimal, we would just add it to 100% and then multiply it by the original amount, okay? If I'm losing you, just hang on, okay? I don't think I need you to write down anything from this slide, though. All right, so let me get over to a problem. All right, here's the problem. You have 2 of these. This is like numbers 20 and 21 on your homework. So if you use this method, it will be on those 2 questions on your homework assignment. It says in 1983, the average price of an audio CD was $21.50. It's actually kind of pricey. Okay. By 2000, the average price had decreased by 34.8%. What was the average price of a CD in 2000? So in example 3, we changed the percent to a decimal and multiplied by the original. You guys remember that? Okay. Instead of doing that, what I'm going to do is I'm going to take my original amount and I'm going to subtract my percentage. Remember, these are percentages. This is important. I'm going to subtract my percentages from each other. So what's 100 minus 34.8? What's that going to be?
66.92.
No?
I got 65.2.
65.2. Okay? But again, this is still a percentage. What do I do before I can multiply a percent times a number? Okay? So honestly, guys, could y'all go ahead and just change this percent to a decimal and not even write this step? Yeah, you totally could. Okay? So, and I won't mind at all if you don't write this step on your homework. If you just go straight from, I do want to see your substitution here. So show me that you're subtracting whatever the percent of change is or adding it. And then you would go 2150 times 0.652. Where did I get 0.652 from?
65.
Yeah, I just changed percent to a decimal. All right, and what do I get?
14.018.
And I have to round that to a penny since it's money. $14.02. Why do you think the cost of a CD would actually go down?
There was.
So is there?
Maybe there's cheaper ways to make it. Maybe the CD is kind of becoming a little more outdated. Don't we stream a lot of our music now?
Yeah.
Okay, so that could be another reason for the price decrease. It's not as much of a demand. But all that to say, basically on this step, what we do, and what would be different in here if it had been a price increase? What's the one thing in this scenario that would have been different?
31.8.
We wouldn't subtract.
I would have added instead of subtracted. So what you can do to find the new amount is add or subtract, depending if it's an increase or decrease, to 100%, change it to a decimal, and multiply by the original amount. There's your new amount. Okay? Like I said, if that's confusing to you, you can do the other method that we discussed in example 3, and I'll go back to that slide really fast, where we had a 2-step process, change the percent to a decimal and multiply by the original, and then you add or subtract it. All right, just by raise of hands, how many people prefer this method over example 4?
Whatever works.
How many people prefer example 4?
Whatever works for me.
Okay? And really, I would say it's kind of a 50-50 split. I don't care which way you do it. All right, if you understand that, that's everything you need to know for 7.5.